solve this, could you tell me what x is?
Yeah.
What?
36.
36. Does that make sense? How did you know that?
Because to get rid of the
Radical.
you have to square it, so you also have to square the 6.
Okay, so is everybody good with that? I mean, did other people do that differently? How many just knew intuitively that that was going to be 36? Obviously, the square root of some number that will give me 6 will be 36. But could I just say, I want to, and this is what Stephen said, he said, well, if I take this and square it, and I take the other side and square it, does squaring a number get rid of the radical?
Yeah.
Okay, so I know that x will equal 36. That, in a nutshell, is our whole lesson.
Easy.
That, in a nutshell, is our whole lesson. So if you can wrap your head around that idea, you are gold. Okay? What?
And here's the part where it gets crazy.
Yeah.
Where
Okay.
it becomes not as simple as we thought.
Oh, it's simple. It really is. That's why I complimented you.
Do we really need a whole page for this?
No, but you might want some examples. Okay?
Oh dear.
All right. Let's start with this one. I'm jumping you right to the top. Okay. And I'm actually going to zoom out because I'm going to give you some directions, and you might want to keep those in your notes. All right, so the first problem is the directions are to solve. Solve always means what?
Find it.
Find x, yeah. Okay, so now I've got red, x plus 7, plus 5, or x equals. And my first step is, let me see, isolate the radical. So what do you think I'm going to do? Subtract 5 from both sides. Okay, so what do I now have? Are we good with that? X minus 5 equals the square root of x plus 7.
Get rid of the red.
So what do I need to do?
Square root.
Square both sides. So I know that when I square x plus 7 squared, what will I have on that side? X plus 7. Okay? And the other side's a little bit more complicated. I know I'm going to have x minus 5 squared, and I know you all know how to multiply binomials, right? Of course we do, okay? And what, you tell me what you get when you multiply that out. X minus 5 times x minus 5 is going to be what? X?
Squared minus 10x plus 25.
Okay, sounds like a plan.
This is so hard.
I know, God.
Oh,
What do you mean this is so hard? Are you making a joke?
no.
Are you sleep deprived?
No,
Yeah, okay. So, right? Are you with me with x minus 5 times x minus 5? You're with me? Okay. And what do you think I'm going to try and do? Okay, I'm going to try to simplify. And in this case, actually, I'm going to subtract, put everything on one side. So I'm minusing the x, and make sure that you also minus your 7. And I am bringing it over.
Do you have to do that? Or can you just, couldn't you just get the x on one side of the,
Okay, but I have x's on one side. Then, well,
like
let's,
add an x to that side?
we're adding an x, and then we're going to have an equal 7. And then I'm going to have 25 on this side. Let's just see what we could do that might just make your life easier.
I get it.
Why do I, what do you get?
nothing.
What do I have? Do I have a trinomial?
Yes.
Okay. Do you want to graph that, factor that, or use the
Factor.
quadratic?
Graphic.
Quadratic.
Holy cow. What are the factors, Zach?
X minus 9 and x minus 2.
Okay, bang, just like that. He recognized the factors of 18 are 2 and 9. Can I factor that in like 2 seconds flat? The time, Kristen, it would take you to write the formula down. The time it would take you to take your calculator out. You should be able to look at that and solve that. Does that make sense to you?
Under 4?
4. I said use the quadratic, but my question to you is, how do you want to solve? Do you want to graph? Do you want to factor? Do you want to use a quadratic? And in this particular case, is there a beauty in knowing how to factor and doing it mentally?
Yes.
Everybody? Yes, I know. That was a little begrudging yes, but you should be able to look and say, oh, the factors of 18, 2 and 9, bang, done. Okay? If that bolt of lightning didn't hit you, could we have done it by graphing?
Yes.
Could we have done it with the quadratic? Absolutely. But you have a little toolbox, and your job is what works, what is the most efficient, and if you think about it, it works. If it doesn't, it's not a big deal. Okay, but don't forget factor. Okay, so do we know what x is equal to? Okay, the problem here, though.
Wait, but that doesn't work if you put it back in.
Exactly. It doesn't work. And my mantra to you, mantra, what is a mantra?
Like a saying.
Save.
It's like check, check, check. This is my little spiel. Check, check, check. Check your work, because when I plugged in the 9, it worked. But when I plugged in the 2, it did not work. And that has a name. It's called an extraneous root. And an extraneous root is a root that is what?
Extreme.
Extra. Okay? And it doesn't work. Okay? And a case in point would be, can I cover this? Are you done? Not yet? Okay, so I'm going to move ahead. If you need more time, you're just going to have to go look at the video, because I want to do 2 things before the bell rings. Okay, and I just would like to make a point. Okay, if I had a problem and I told you x is equal to 5, so I'm telling you what the value is. Okay, and then I said to you, well, can you tell me what, can you solve for x? And you would say, okay, well, I can square both sides, and x squared is equal to 25, so x is 5 or a negative 5, correct?
Correct.
But I told you from the beginning that x was equal to 5. Now, it happens that x, in other situations, x is equal to a negative 5. But in this particular case, it would be an extraneous solution. It's a solution that doesn't work. And it happens because we have a number that is squared and it has a positive and negative. So you always have to check your answer on these problems. Okay? All right, next problem.
What are these called?
Radical equations. They're all involving a radical. Okay. And this one, you know what, we're going to run out of time, so these are in your textbook. Now I'm going to let you copy them from your textbook, but I want you to just see this. Okay, solve by raising to a power. Now in this case, same directions. I want you to isolate the radical. Okay, isolate the radical. So I'm subtracting 2 from both sides. And now I have the cubed root of x minus 5 equals 5. Well, I'm going to cube both sides. And if I cube this, do I get the number without the radical? Then I have to remember to cube the 5. And then I can solve at 5. And I know that x is 130. And when I check that, there was only one solution in this particular case. So I have 5 is equal to 5. Okay, one more, and then I'm done. And I have about a minute, hopefully. Nancy doesn't start talking. Okay, and this one, and again, these are examples, and I did them intentionally to be out of your book so that you could look at them again if you needed to. And this one was, look at this. Solve for x to the 3/4. Okay, so again, I'm going to try to get my x by itself. So I'm going to divide by 4.
And you solve by raising to a power.
And then I have x to the 3/4 is equal to 27. Now there's two things that I want you to pay attention here. I would like to get rid of that exponent. Hold on, Nancy, stop talking. So if I multiply 3/4 by 4/3, remember I am raising an exponent to a power. What is the rule?
You multiply.
Multiply. So if I have 3 times 4 is 12, and 4 times 3 is 12, I have 12 over 12, or x to the first power. Slick. Okay? So it is, it's elegant. Okay? It's called using what you know. And so by doing that, I have x to the first. Now hold on, wait a minute. Let me, my last sentence. I'm going to give you homework, so don't run out the door. Page 501. 4 through 27 odds. No, yeah, 4, 5, and then 5 through 27 odds. I will put it on. Is it on?
What page is that?
4 and 5.
Page 501, I believe.